Hello everyone. Today we are going to discuss about the Docker. Before discussing about the Docker, let's do a quick intro to containers and VMs. So what are containers and VMs? Containers and VMs are similar in their goals. What is the goal? To isolate an application and its dependencies into a self-contained unit that can run anywhere. I would say if you have containers or a virtual machine, they are going to serve for the same goals. And what is the exact goal? To isolate an application and its dependencies into a self-contained unit that can run anywhere. We are going to have a detailed discussion how we are going to isolate an application and its dependencies into a self-contained unit. Moreover, the containers and VMs remove the need for physical hardware, allowing for more efficient use of computing resources, both in terms of energy consumptions and cost effectiveness. In both the cases of containers and VMs, what we are going to do, we are going to remove the need of physical hardware. Okay. On top of the hardware, we are going to install some set of hypervisor, or I would say the Docker engine. The main difference between the containers and virtual machine is in their architectural approach. So what is the basic difference between the containers and VMs? It is all about the way we are going to install the hypervisor, or I would say the Docker engine. The end goal or the purpose of both the containers and VMs are same. So if you see in this example, this is our hardware, and in this hardware what we have done, we have installed one operating system, then we have our hypervisor, and then we have, I would say, virtual machine 1 for my application 1, same for my virtual machine 2 for my application 2, and virtual machine 3 for my application 3. And each virtual machine has its own operating system, binaries, libraries, and it's on the top of this one we have our application 1. In the same way we have configured for VM2 and VM3. In the virtual machine, what is the exact benefit? Since the virtual machine has a virtual operating system of its own, so we are good to say the virtual machine is directly proportional to the operating system. So each virtual machine will have its own operating system, its own binaries and libraries, and top of that one, what we are good to do, we are good to deploy our application. While in the case of containers, what we have our hardware, then on top of this one, we have our operating system, then we have installed what? We have installed our Docker engine, or we are good to say the container engine. And then for each application, I would say for application 1 we are good to have one container, then the container 2 is deployed for application 2, and for application 3 we have the container 3. But here we do not have the, I would say, dedicated OS for each container. In this case what we are doing, we are going to use the host operating system to run our configuration. That is the basic difference between the containers and virtual machines. If you see in this diagram, what we have the operating system for each of our virtual machine, while in the case of container we do not have the dedicated operating system. The operating system, it is going to be shared among the multiple containers, but each container will have its own binaries and libraries which are required to run our application. So let's try to understand the dedicated machine, the virtual machine, or container solution in terms of one problem statement. So what is the problem statement? Let's say you had a single dedicated server that was running your PHP application. When you initially deployed the dedicated machine, all three of the application which make up your e-commerce website work with PHP 5.6. So there will be no problem with compatibility. Okay, so what is the use case? Currently we have our hardware, I would say. On top of this one, what we have our operating system, and here we have deployed the application 1, then we have application 2, and finally we have the application 3. Your development team has been slowly working through the three PHP application. You have deployed it on your host to make them work with PHP 7, so as this will give them a good boost in performance. So what we have planned, initially what we have done, we have the version 5.6, but what we are planning to do, we are planning to upgrade the PHP version from 5.6 to version 7. And what is the benefit? Definitely it is going good boost in performance. However, there is a single bug that they have not been able to resolve with application 2, which means it will not run under PHP 7 without crashing when a user adds an item to their shopping cart. Okay, so what is the issue here? The application 1 is compatible with version 7. The application 3 is also compatible with version 7, but our application 2 is not compatible with our version 7. What is the issue? When a user adds an item to their shopping cart, the application is getting crashed. Okay. If you have a single host running your three applications, you will not be able to upgrade from PHP 5.6 to PHP 7 until your development team has resolved the bug with app 2. So what is the issue here? I would say we have our operating system, and the top of this operating system we have deployed all our three applications. Application 1 and application 3 is okay with version 7, but application 2 is not compatible. So if I'm going to upgrade the version from 5.7 to 5, I would say from 5.6 to 7, then we are going to have issue with our application 2. So what would be the solution? Deploy a new host running PHP 7 and migrate application 1 and application 3 to it. This could be both time consuming and expensive. What is the second option we have? Deploy a new host running PHP 5.6 and migrate application 2 to it. Again, this could be both time consuming and expensive. So initially what we had this server. On top of this server, we have installed our operating system. We have our application 1, application 2 and application 3. As we have discussed, this application 2 is not compatible with PHP 7. So in the first case, what we are suggesting, we are going to have a server, or good to say, I would say hardware component. Then we are going to have the operating system, and here we will deploy our application 1 and application 3. And the PHP version, it would be 7. The second option which we have discussed is we have our server, then the operating system, and the PHP version which we are going to have is 5.6, and we are going to deploy our application 2. But in both the cases, it is going to be time consuming and expensive. The third option which we have, wait until the bug has been fixed. The performance improvements that the upgrade from PHP 5.6 to PHP 7 bring to the application could increase the sales, and there is no ETA for the fix. So what is the third option which we have? We are not going to upgrade our PHP version from 5.6 to version 7. What we are going to do? We are going to wait to sort out this issue of application 2 with the compatibility of version 7. But this solution will definitely impact our sales growth and the performance. So this is the typical problem which we are going to get if we are going to use a dedicated machines. Let's try to solve this issue using virtual machine. One solution to the scenario detailed earlier would be to slice up your dedicated machine resources and make them available to the application by installing a hypervisor. Once installed, you can then install your binaries and libraries on each of the different virtual hosts and also install your application on each one. And then you will be able to upgrade to PHP 7 on the virtual machines with app 1 and app 3 installed while leaving app 2 untouched and functional while the development work on the fix. So in this solution, what we are going to do, I would say we are going to have our hardware, then we are going to have our operating system, then we will install our hypervisor. I'm just ignoring, we have the two options of hypervisor, type 1 and type 2. Okay, so that is totally a separate discussion. Our main agenda is to focus on containers. So I'm just saying, on the top of the operating system, what we have done, we have installed the hypervisor, and for each application, I would say app 1, app 2 and app 3, what we are going to have, for app 1 we are going to have a dedicated operating system, For app 2, we are going to have a dedicated operating system, and same for app 3. So we are good to upgrade this version from 5.6 to 7, and same we are good to do it for application 3. And for application 2, what we are going to do, we are good to wait until and unless our bug is going to be sorted. So what is the catch? From the developer's view, there is none, as they have their applications running with the PHP version which work best for them. However, from an IT operation point of view, so from the IT team, so what are the challenges we are going to have? More CPU, RAM and disk space. Each of the virtual machine will require additional resources as the overhead of running the 3 guest operating system, as well as the 3 application have to taken into account. So what would be the challenge in terms of IT admin guy? We have to manage a 3 operating system. So what would be the challenge here? While creation of virtual machine 1, virtual machine 2 or virtual machine 3, at the creation time only we need to allocate a dedicated amount of CPU, RAM and disk space. So it depends upon the application uses. If this application is going to use, I would say 30% of the CPU and RAM only, but 70% of the resources are going to be underutilized. This is the challenge while using the virtual machine. At the creation time only, we have to allocate some specific amount of CPU, RAM and disk space. While in the case of management, IT operation now need to patch, monitor and maintain 4 machines. The dedicated host machine along with 3 virtual machines, whereas before they only had a single dedicated host. While in this case, what they are going to do, they are going to manage 3 virtual machines for each applications and 1 dedicated host. So it would be too much work for the management team. While in the case of dedicated machines, I would say there was so many challenges, but still one of the advantages was we only need to manage 1 host. Okay, let's try to solve this issue using containers. Here we have our dedicated machine solution, the hardware, the infrastructure, then our operating system, then binary libraries, and then we are good to deploy application 1, application 2 and application 3. We already have a very detailed discussion what are the challenges we are going to get if we are going to use a dedicated machine. While in the case of virtual machine, we are going to have a virtual machine 1 for my application 1, virtual machine 2 for my application 2 and virtual machine 3 for my application 3. But the challenges it would be, at the time of creation of this virtual machine 1, 2 and 3, we have to give a specific amount of CPU, memory and disk space. And the other challenges it would be, we need to manage 4 servers. 3, it would be my virtual machines, and the 4th one, it would be my dedicated machine. Let's try to solve this issue using containers. Let's look at what container add to the mix. Installing Docker on the host and then deploying each of the application as a container on this host give you a benefit of the virtual machine. Okay, while vastly reducing the footprint, that is removing the need for the hypervisor and guest operating system completely, replacing them with a slimline interface directly into the host machine kernel. So the first solution which we have discussed using dedicated machine, it is a very old approach. In recent time, you will not see any application deployed to our dedicated machine. The second option which we have discussed is using virtual machine. But the problem with the virtual machine, at the time of creation, we need to allocate some specific amount of CPU, memory and disk, and that would be specific to the virtual machine only. The second challenge in terms of management. While in the case of containers, these things are going to be sorted. How? In terms of low overhead. As mentioned already, the resource and management for the IT operation team is lower. The second option is development provide the containers. Rather than relying on the IT operation teams to configure each of the 3 application environment to machine the development environment, they can simply pass their containers to put into production. As we have discussed, the architecture of container is we are going to have our hardware, then our operating system, and then top of this one what we are going to have, the container engine, I would say our Docker, and then we are good to deploy the container 1, the container 2 and container 3. While in the case of management, it would not be challenging as our virtual machines. And in terms of resource management, while the creation of this container 1 or container 2 or container 3, we do not need to allocate any specific amount of CPU, memory and disk space. Okay, as per the requirement, it is good to fetch the CPU, memory or disk space from my dedicated machine. So these are the one of the advantages why people are moving towards the container. Apart from this, we have n number of benefits which we are going to discuss in our upcoming videos. Is Docker our only solution? The answer is no. One thing which we have to understand, there is one concept which is called as containerization. And using this concept, what we are going to create? We are going to create containers. And there are n number of vendors which support to create these containers. And one of them is what? Docker. We have Alexi, which is called as Linux containers. Then we have container D. Then we have, I would say, RKT. There are n number of vendors which generally provide the supports of creation of containers. So Docker is widely used. That's why it is very famous in containerization world. So in our Docker architecture, we have the three components. The first one, it is called as client. The second one, it is called as Docker host. And the third one is called as registry. We are going to run Docker commands, and each and every Docker commands start with Docker and then whatever you want to achieve. And then this Docker command is going to interact with my Docker daemons, and there are two components in our Docker daemons. One, it is called as our containers, and the second one is called as image. Okay, and then if the image is locally present, then it is good to create the container from my image, or else it will connect to my remote repository where we have all our images present. And one of the famous remote repository is Docker Hub, where we are good to see n number of images for each and every kinds of application. We are going to have a very detailed discussion. What is images? What are the various options to create the images? How containers and images are interrelated with each other, and the other components. So the next thing which we are going to do is downloading and installing Docker. So what I'm going to do, I'm going to create a Ubuntu virtual machine, and top of this virtual machine, I'm going to install Docker. And once my Docker is installed, I'm going to create n number of containers, and then we will discuss about how the containers and images are related to each other, and what are the various ways to create the containers and the image, and what are the other Docker's command we have. So let's firstly create a Ubuntu virtual machine and then install a Docker. So I'll click on create virtual machine. I will say demo-rg. It is already created, so I'll mention demo-rg1, then demo-virtual machine 1, and the image version which I'm going to use is Ubuntu. The size, it looks good. Let me use password. The username, it would be Akash. I'll mention the password. Then I will click on review plus create. So my resource has been created. I'll click on go to resource. Okay, we'll copy this public IP address, and I open my PowerShell, clear my screen. We'll mention SSH AKSH. This was my username, and then my IP. I'll mention yes. It will ask for my password. What I have done, so currently I'm logged in inside my virtual machine. I have created this Ubuntu virtual machine. What I have to do, I have to install Docker. So let me update my package list. I'll mention sudo apt update. So after updating my package list, let me add Docker's official GPG key. And then I will add the Docker repository. We'll press on enter. And then I will install Docker. There's one typo. I will remove this. Sudo apt update and press enter. Press Y. And so Docker has been installed in this virtual machine. Let me switch to root user. So I'll run a command called systemctl status docker. And if you see what is the state of my Docker, it is in a running state. Let me clear my screen. And the first command which I'm going to run is info. We are good to get each and every detail information regarding the client, the version which we are using, the plugins, in terms of server, how many containers we have, what is the how many containers is running, paused and stopped, how many images we have, and the other configuration detail. So as I have mentioned in Docker, whatever the command we are going to run, the first thing which we have to mention is Docker, and then we are good to mention the other arguments. So the next command I'm going to run, which is called as Docker images. As we have discussed, in Docker, what we are going to create, we are going to create what? Containers. The way in virtualization, what we are going to create, we are going to create virtual machine. In the same way, in containerization, what we are going to create, we are going to create containers. Okay, and to create this container, what we need images. And if you want to list all the existing image in your machine, what you have to run? You have to run a command called Docker images. Okay. Then the another command which we have, which is called as Docker PS. PS means process status. It will list all the running containers in our machine. Let me quickly clear my screen. And this time what I'm going to do, I'm going to create what? A container. To create the container, the command is Docker. As I have mentioned, to run any command in Docker, the first thing which we have to mention is Docker. The second thing which we have mentioned is run. So what is the purpose of run? Run will create and start my container. Okay. And the third one which we have mentioned is -d. The purpose of -d, once my container is created and it is in running state, what it will make sure my container will run in the background. Okay. If I'm going to run this command, so after running this command, my container will be created and it will be started, but it will be running in background. At the terminal end, you will not logged in inside the container. Okay. What is the third command which we have mentioned? We have mentioned -name is equal to hello. So we need to pass the container name. And to pass the container name, what we have to mention, we have to mention hyphen hyphen name and then the value. And the fifth one, what I have mentioned here Ubuntu. I want to create a container name called as hello, but what would be the image? The image name, it would be Ubuntu. And finally, what we have mentioned? We have mentioned bin forward slash bash. That would be the terminal which is going to be run after creation of our container. Let me press enter. And if you see here, my container has been created. Let me run a command called docker ps. And what is the full form of ps? Ps means process status. And finally, my container has been created. And what is my container ID? This is my container ID and the image which it has used, Ubuntu. And this is the command which we have mentioned. And it is created around 12 seconds ago. And the status is around 11 seconds ago. We have not exposed any ports. And what is the name of my container? The name of my container is hello. Okay. If I'm going to create a container without any name, then see, are we going to get any kind of error or not? So the first thing which you have to notice, my container has been created. I will run a command again, docker ps, and see, we have not received any kind of error while creation of my container, and Docker has given some random name to my container. So while running this command, if you're not going to mention any container name, so Docker is going to provide some random name to my container, but it will not give any kind of error. Let me run a command called docker images and see. So initially when we initiated this command, was there any image present in my local machine? The answer is no. When we firstly created our, I would say, the first container, what we are able to see, unable to find image Ubuntu colon latest locally, means we do not have the Ubuntu image present locally in my virtual machine. What it has done, firstly it has searched in my local machine, then it has pulled the image from the Docker hub, and after pulling the image from the Docker hub, it has created the local copy. That's why we are able to see the image present here. And when we initiated the second container creation, I would say here, my second container, if you have noticed, while the creation of my first container, it took around 2 to 3 seconds. But here it was created within millisecond. Why? Because while creation of my second container, we have asked for which image? The Ubuntu image. And as we have discussed, during our first creation of container, what it has done, it has searched the image locally and it was not present, so it has downloaded the image from my Docker hub. And while the creation of my second container, I would say container 2, it was very fast because the Ubuntu image was present locally. Okay. And the other reason is also we have, while container does not have its own operating system, I would say, let me create a container name called as hello one, and let me remove hyphen d. Okay. So as we have discussed, what is the purpose of hyphen d? It will make sure the container run in background. Okay. Let me press enter and see. After running this command, we are directly logged in inside where? Inside my container. But if you have noticed here, when I created this hello container, was I directly logged in inside the container? The answer is no. Why? Because I have mentioned hyphen d. And what is the purpose of hyphen d? Once my container is going to be created, it will run in the background. While in the case of second container also, my container was running in the background. But here what I have done, I have removed -d. That's why we are able to log in inside the container direct. So this is a basic difference if you are not going to use hyphen. The another command which we have, it's called docker inspect, and let me mention the container ID and see. After running this command, we are going to get A to Z information regarding our containers. We are good to mention the container ID or the name of my container. Let me run it again. Docker inspect. Hello, and see the same thing. It will have A to Z information regarding my container, like the ID, when it was created, the state, the image, the host path, and the other configuration. And let me run this command again, docker info. And if you see here, in terms of client, it has the detailed information regarding the version which we have already discussed. But here if you see the containers, it is showing three. Two of the container are in a running form, one of the container is stop, and how many images we have? We have one images. So using a docker information, we are good to get the overall information regarding our docker engine, docker regarding our docker daemon, docker client, and the other configuration in terms of CPU, memory, and the other details. So till now what we have discussed some of the basic commands of docker, then we discussed about the containers, and then while creation of my container, if the image is not present locally in my machine, then what it is going to do, it is going to download the images. I would say download the images from Docker Hub. Okay, so if you want to download, or I would say to pull some specific image from Docker Hub, so the command is docker pull and the image version. So what I have done, I have mentioned docker, then the pull command, and here I have mentioned what is my image name and the version which I have mentioned. If I'm not going to mention any version, then by default it will pull the latest. Let me list the new images. I'll mention docker images, and here if you see, we have two versions of Ubuntu. One it is latest, the other one is 18.04, and these are the image ID and when it was created and the size. Docker ps. So currently how many containers we have? We have the two containers. If you want to stop any container, so the command is docker stop, and I'll good to mention the name of my container or the container ID. I'll mention the name. So it will take some 5 to 10 seconds to stop my container. So finally, my container has been stopped. If you have noticed, the docker stop command stop the containers gracefully. But apart from docker stop, we have one more command which is called as docker kill, which is going to stop the container immediately. Let me mention this container name. And if you have within a millisecond, it is going to stop my container. And if I'm going to run a command called docker ps, it will not show any containers because both of my containers are in a stop stage. So what I have to do, I have to mention docker ps -a, and as you can see here, we are able to see three containers and all the three containers are in a stop stage. So if you want to start the container, we are good to mention docker and then my container name and enter. So my container has been started, and if I'm going to run docker ps, it will show my container is in a running state. If I need to log in inside this container, so the command is docker attach, and I'm good to mention my container name. And right now I'm inside my container, and if I'm going to run a command called ps aux, and if you see here, what is my, we are going to have one process id 1 which is running inside my container, and if I'm going to come exit of my container will be in a stop stage. Let me mention docker ps. So what happened in this case, if I'm going to use attach command to log in inside my container, it is not going to create any new process. It is going to use the existing process. So once we are going to come outside of my container, so it will kill my main process ID, which is a 1. That's why my container is in a stop status. So the other option which we have is using exec. Okay, so what is exec is going to create one process inside my container, and once we are going to come exit from this container, it will not stop the process ID 1, but it will stop the process ID using which we have logged in. So let me firstly start my container. I would say docker start. So what was my container name? I would say hello one. My container has been started. I will run a command called docker exec -it, and what was my container name? Hello one and bash. So in this case, what it is going to do, it is not going to log in inside my container using the process ID 1. It is going to create one process for this bash, and using this one we are good to log in inside my container. Let me press enter, and if I'm going to run a command called ps-aux, and see, we have a dedicated process ID name called as 17 for this command. And if I'm going to come outside of this container and let me run docker ps, my container will still be in a running stage. Why? Because it has killed this 17 process only. But while in the case of attach, it is not going to create a new process inside my container. So once we mention the exit, it has killed the process ID 1. So till now what we have discussed, I would say, we have created the containers, and to create a container what we need an image, and if the image is locally present it is good, or else it will pull the image from my Docker Hub. Then the second thing which we have discussed in container is the inspect command, and the third one which we have discussed is how to stop the container, and what is the difference between the stop and the kill. And the fourth one which we have discussed is the difference between the attach and exec. Okay, so finally the last command which we are going to do is, I would say, docker ps we have running this container. I will run a command called docker rm and then my container name. So here we are getting an error. The error is response from daemon cannot remove container hello1. Container is running. Stop the container before removing or force remove. So if you want to forcefully remove the container without stopping it, so the command is docker rm -f, the container name or container ID. And see, if I'm going to run docker ps, my container has been removed, and I will run docker ps -a. So my container is not showing here also because it has been removed from my container list because I have mentioned -f. Or else if you want to delete the stop container, the command is docker rm and then hello. So here if you see, my container has been removed because it was in a stop state. So with this we have completed our day 1 discussion. So in the next video we are going to discuss about the docker images and what are the various ways to create the images and what are the best practices. Thank you.